Hello everyone, my name is Syed Ahmad Jamal and I am from Karachi, Pakistan. I am currently a third year student of Electronics Engineering at NED University of Engineering and Technology, Karachi. For this competition, I have simulated how an AM, Amplitude Modulation, Modulator and Demodulator work. And just before diving into the simulation, let me briefly explain what an AM modulator and demodulator are. So as you guys see, this is the block diagram of our circuit, and there are four main blocks in this block diagram. First one is this one, message signal block. Second one is the carrier signal block, and third and fourth is the modulation and demodulation block. I will start with an example. Like imagine listening to your favorite AM radio station during a road trip. The voice or music you hear is transmitted as an amplitude modulated signal and demodulated by your car's radio system to produce sound. So in this example, this circuit is at the AM radio broadcasting station, and this circuit is at your car radio system. In between that there will be a transmitter or a receiver. So for starting with the message signal, let's suppose at the station AM radio broadcasting station, this is the music you want to listen. This is our message signal. It has a certain type of frequency, and after that carrier signal. What is carrier signal? Carrier signal is the signal which carries your message signal to over a long distance. As you know, you are driving the car and you are going at a long distance or a long route. So this signal has a higher frequency component, and this signal carries your original message signal to your system. And how this is transmitted? This is transmitted by superimposing the message signal onto the carrier signal. In this block superimpose both these signal. It contains such type of electronic circuit which superimpose these both signals. And after that there is the output of the modulation block is the one signal which is called modulated signal, and that modulated signal is transmitted over a long distance with the help of antennas or transmitters. And when your cars receive this modulated signal, there is such type of electronic circuit which receive that modulated signal, and from that modulated signal it extract that message signal which is the music, and you hear and listen and enjoy your music at the output. So this is the output of the demodulation block. So let's go on the MATLAB. Let's forget about this scope. This scope is to visualize these frequencies. In this simulation, I use 10 Hz of message signal and 300 Hz of carrier signal. See, this is 30 times greater than message signal, so that's why it can carry a small signal and over a long distance. Now these four signals were the input of this block. Let's see what is the message signal look like. How does the message signal look like? The message signal look like this. This is the message signal frequency, and this is the carrier signal frequency. See, the frequency is greater than message signal, and these both block is going and with the input of the modulation block. And after that this is the output which is called modulated signal. And how our modulated signal look like? Our modulated signal look like this. This signal is transmitted over a long distance easily. Now at the receiving end, this block is such type of electronic circuits which demodulated and extract that information, and after that the signal look like this, which is exactly as our input signal. If I will see, there are the original message signal look like this, and at the output our message signal look like this. Although it's a certain type of components on circuits and such type that the amplitude goes up to the x-axis, and it is looking like this, but at the output we almost we can say that 90% of our signal is delivered or extracted at the output. So this is it, the demonstration of how a modulator and demodulator works. It's a plenty of application. It is used in communication systems, and it is used in aviation communication system, two-ways radios, signal transmission in remote areas. So these are the four big application of this circuits, and this is very basics of it. I have just taken ideal frequencies 10 Hz and 300 Hz. In practical, this is far much than the Hz. So this is it. As you see in this simulation, I used signal generator. As you see, sine wave generator. These are the sine wave generator. But in practical, we doesn't use sine wave generator. We can use the function generator for the input, but the more professional way, you can make your own oscillators. So I just have added oscillators. For example, you can use Wayne bridge oscillators, Colbert oscillators, and there are many oscillators for sine wave generation of different frequencies. And in the modulation block, in the above block diagram, the modulation block carries some modulation circuits, which is also I have added two pics of modulation. There will be an balanced modulator, switching modulator, ring modulator. The ring modulator in practical look like this. Square modulator in practical look like this. It will make with the help of an op amp. So these are such type of modulators. And after that, in the demodulation block, we have such type of circuit like envelope detector, square detector, product detector, synchronous detector. And I have just attached one photo of envelope detector. The envelope detector look like